All right. Well, thank you very much, Victor. Thank you to the Cloud Security Alliance of Southern California for having me for this talk. I would ask you all how the weather in Southern California is right now, but I think I already know. It's probably wonderful. I'm in Syracuse, New York right now. The weather's actually not bad. But we're not here to talk about the weather. We're here to talk about malware analysis and specifically how we can move malware analysis to the cloud. And really what this talk, what I want to focus this talk on is an analysis of the risk involved with using malware analysis instruments in cloud resources. And so this is an exploration and a discussion of can we move the process of slicing malware, known malicious binaries open on cloud infrastructure? Can we move that to the cloud and have it be secure, have it be safe, and have it be the best combination of convenience and security? I want to just quickly mention that the slides and the code for this talk are available on my GitHub page. I just made the repo public like 45 minutes ago, so you should be able to go to my Husky Hacks, my account Husky Hacks on GitHub, and the repository in there is called Cloudy with a Chance of Malware. That has the Terraform code that we'll be demonstrating today. That has the slides as well. So here's a brief overview of what we're going to talk about in this discussion. I'm going to give my introduction, but really we're going to talk about the old, not necessarily the old way, but the previous way of performing malware analysis, which has a lot to do with provisioning local virtual machines, how we are going to move that to the cloud. And I think the most important part of this discussion is this bullet point right here: considerations, security, and guidelines, because we want to make sure that we're doing this in a way that doesn't expose infrastructure or potentially put infrastructure in harm's way. And then we're going to do a little tech demo. So I'm actually going to spin up some infrastructure. I say that this is rapid deployable cloud malware analysis infrastructure, and you're going to see how rapid that is. And then I want to leave enough time for questions and comments as well. So I'm not great with the Q&A of Zoom. I will try my best to pay attention to it, but sometimes I really get in the zone. If you have a question, please put it in the chat or the QA, and I will gladly answer it as well. But who am I and why should you be paying attention to me? Really, I'm just kind of a guy that's kind of learning things on the fly here. But I'm a security researcher. I primarily am a red teamer and offensive security researcher, but I also have developed a malware analysis skill set. And I like to think that those two things are not super different. Malware analysis feeds into offensive research, and offensive research feeds into malware analysis. They're two sides of the equation here, and I like to take one and employ those skills to make the other one better. But really, just right now, my 9 to 5 right now, I am a principal security researcher at Huntress. So we do small to medium businesses. We do cybersecurity, defensive technology and products for small to medium businesses. And I have hiked the Appalachian Trail. I've hiked Mount Kilimanjaro. I like hiking in general. But yeah, that's just a little bit about me. But let's get into the talk here. So the genesis for this talk is about my course that I have on TCM Security Academy, which is Practical Malware Analysis and Triage. So I teach the art and science of malware analysis to now about I want to say it's probably closer to 39 or maybe even 40,000 students around the globe. And so this is everything from a very early introduction to, what malware is and how to handle it correctly, all the way through advanced dynamic and static analysis. So we are slicing binaries open and looking at them at the very lowest possible level that you can look at. And then we speak a little bit about how to set up safe lab infrastructure, how to do report writing, just running the gamut of all matters of malware analysis. But so specifically, I, as the instructor, have a mission here, and my mission is to give the student the tools necessary to succeed out in the world when it comes to malware analysis. I want them to be able to come to any organization that employs this skill set and hit the ground running. And a sub point of that is to give students the tools that are necessary, the industry recognized tools that are necessary to be able to do that. And so a malware analysis lab is a key part of that tool set. And so the course introduces students to building locally provisioned virtual machines to be able to perform malware analysis safely from within their personal home networks. Now, the way this usually ends up looking is that there is the student's personal computer, which they already have. As a side note, they have to be able to run virtual machines in the x86 architecture, so that kind of limits some students. We'll come back to that point here in a moment. But the first thing that we do is we install a normal virtual machine hypervisor. In the course, we install VirtualBox, and that is because VirtualBox allows you to take snapshots and revert back to snapshots. Inside of this hypervisor, you then build either a host-only or an internal network that is isolated from your physical host. And that is because when we provision our two virtual machines that we will use for malware analysis, one of them is Flare VM and the other one is Remnux. If you're not familiar with these are industry standard malware analysis platforms. One of them is Windows, one of them is Linux. And so these are the platforms inside of the malware analysis network that the student will use to be able to slice open their samples. And the interesting and important thing to note here is that dynamic analysis is performed on the Windows virtual machine. And so you actually, what we refer to as detonate malware, you run malware to analyze it dynamically and look at the processes that it's creating, the DNS requests that it's making, the HTTP or HTTPS requests that it's making. And that all happens from within this malware analysis network. And you, if you have set the network up correctly, you have isolated that network so that all of the traffic that would originate from a malicious sample and try to egress and go find a command and control server somewhere on the internet is going to be stopped at the network boundary. I would hope that the attendees in the audience today would look at this setup and say, Matt, what were you thinking? So I like to believe that the fine people of the Cloud Security Alliance would look at this and say, wow, you've got all kinds of issues that you probably deal with. And in truth, yes, that this is a very tricky setup to do at scale across the globe with students that have varying levels of familiarity with virtualization. They have various architectures, they have various setups. And so this also takes time to set up. You have to provision the virtual machines and run the installation scripts. Anybody familiar with that will probably know how much time that truly takes up. And this really just does not scale well. It's workable. If you know enough about virtual machines, you can get it to work. But this is not a great solution. It works. It's not great. So the common challenges here are things like if a student has a Mac on an M1 or an M2 chip, they can't even run x86 architecture in the first place. Usually, I'll speak generally here. There's variability in the computers and the VM performance. And one of the biggest ones is that one highlighted in green right there. And that's risk. A lot of students, rightfully so, have come to me and say, hey, Matt, I really want to do the course, but it's kind of, it's freaking me out that I'm going to be detonating malware on my own home personal computer where I have my pictures and my videos and all of my precious files. And rightly so, that is a very real concern. And so eventually it got to the point where I kind of took a look at this and I thought, is there another way that we could do this? Is there an easier way to scale this? Is there a better way, a more secure way that we can offset the risk of malware analysis and put that somewhere else? And so what it comes down to is we will, in theory, benefit greatly from moving this to the cloud. But there are considerations here. So essentially what ended up happening was at the outset of the course, I was not particularly familiar with AWS. I'd used it before, but I wasn't familiar with Terraform or standing up AWS infrastructure at scale in a scripted kind of continuous integration, continuous development fashion. But one of my students was a gentleman by the name of Adan Alvarez. And he came to me and he said, hey, I'm really good with AWS and I did malware analysis in your course. And I've created an architecture and I want you to take a look at it and see if this would be a good architecture to run on an AWS instance. So I took a look at it and it was fantastic. And I said, this might be perfect. I did some tinkering to it. I refined it a little bit. And then we now have, at least in theory, the rapid deployable malware analysis lab that we will be using. But we can't just launch right into this because there are like a lot of other kinds of like a lot of things on AWS. There are terms and conditions. There are security guidelines that you have to follow. Anyone who's ever done any kind of red teaming or penetration testing using AWS infrastructure knows that this is the case. And so there is a form that you would need to fill out if you're doing any kind of pen testing from AWS. It turns out that this form is the same form that you have to fill out if you want to do malware analysis as well. It's called the Simulated Events Form, and it is a form that you submit to the AWS Trust and Safety team, I want to say. And this form will outline your architecture. It will stipulate a bunch of considerations, and you have to meet those considerations in order to perform malware analysis on the endpoint. Now, the other considerations here, just like any other kind of AWS Terraform provisioning, there's some assembly required, right? You're going to need AWS CLI, you need Terraform, you need all manner of things to actually get these instances provisioned. And I want to put a little caveat here about the cost of this. It's low cost, it's not no cost. I found that the tier 2 medium instances do the best with, regards to good performance, but cheaper. Anything lower than that, you're probably going to get performance issues. Anything higher than that, you're going to, pay a lot. And I have 2 pre-built AMIs for this, and I foot the cost for the storage of those AMIs. But this is just the stock configuration. You can make your own AMIs if you want to do this. From the simulated events form, verbatim from the text itself, this is what is required of you if you want to do malware analysis on the endpoint. This will be carried out on a secure VPC. The VPC and instances will have inbound traffic restricted. The VPC instances will not have any public IP addresses. They can't send packets to the internet. DNS should be disabled. There's a caveat about things like DNS emulation, which is something you do in malware analysis. You should detonate it in a sandbox. And there are a few other stipulations here. And I want to point out that I think the AWS Trust and Safety team has done a pretty good job, but I think there is more clarity that could go into this. And so this is kind of my call to action to the community. Let's start the conversations about specifics here, right? And so in the simulated events form, there's really no prescribed architecture here. As long as you meet these requirements, you can carry out malware analysis. However, I have had students that have submitted this form with the architecture I'm about to specify and been denied. And I think that that's not necessarily a fault on either side here. I think that the clarity of these instructions could be refined. And I want to actually help with this. So if anybody knows anybody on the AWS Trust team, please let me know. I'd like to talk to them about it. In any case, when we took a look at what we needed to put together for the secure architecture, this is what I came up with. So let's zoom in and talk about it. All the way at the bottom of this graph right here, let's do pen here. All the way at the bottom of this graph, this is the computer that the students of PMAT will use in their day-to-day life. All this really, means is that there's some kind of client that has a web browser associated with it. And right about here is the network edge of that student, right? So this is their firewall, and from here, this might be their home network over here, but up out here, this is the public internet. So everything above this red squiggly line right here is the open internet, and the student will have a publicly routable IP address. That publicly routable IP address will be dynamically allow listed by our infrastructure when we set it up, and we use a little bit of Terraform magic to be able to do that. And so Apache Guacamole is the first stop in our infrastructure. So this right here is our Apache Guacamole instance. And if you're not familiar with Apache Guacamole, what you can do is you can sign into Apache Guacamole and have remote desktop access and SSH access and VNC access to other things inside of a secured network. So think of this as our jump box. This is our vantage point into the lab. On the outside, it is locked down to only the student's IP address. And on the inside, everything inside of this VPC does not allow traffic out of this VPC. And then like the previous setup for this lab, we have Flare VM and Remnux, and all traffic in the internal subnet is allowed to route to each other, but there is no egress traffic in its default configuration. So in other words, if we detonate malware here, if we detonate some piece of malware and it reaches out to the internet, it's not going to egress out of this network. It's going to stop at the network boundary, and that's enforced by AWS security groups. And like I said before, our vantage point into the lab, the way that we can actually interact with our lab safely is through Apache Guacamole. We sign into Apache Guacamole, and we can then remote into Flare VM or Remnux or both and perform our analysis activities. All right, I put this in here because I will otherwise forget to start the lab here. So we're going to go ahead and bring up my code repository here. And as you can see in here, I have my Terraform files. I think I can make this a little bit bigger. So the demo to actually do this is, let me grab my notes here. Got to get all the Zoom windows out of the way here. So these are 2 Terraform commands here. Terraform, and of course you would Terraform init if you've never run Terraform in this case, but I have done that already. So we will Terraform plan. So this is going to take all of the .tf information stored in the .tf files, and it will provision, or at least it will plan to provision, our rapid deployable malware analysis lab. I know that you see that there are plain text credentials in here. I understand and acknowledge that, but don't worry about it. That's going to tie in here in a moment. And of course, if we Terraform apply and we wait here, I always forget this. If we wait here and it's got to say, hey, we're going to go ahead and apply this. Do you want to? And we do yes. We begin the provisioning of our Terraform infrastructure, or our AWS infrastructure. This is going to run. This takes about 5 minutes. So I'm going to boot this over to the side and continue on with the demonstration. So one of the important things here to satisfy the requirements from the AWS Trust team is that we need to implement all of our security provisions, or our security configurations, when we provision these instances. And so the idea here, and people in the CI/CD pipeline world are probably familiar with this, you're doing security as architecture and you're doing architecture as code, right? And so Terraform's wonderful because it allows you to not just provision the AWS infrastructure the same way every single time. It also allows you to stand up the security of that infrastructure repeatedly every single time. And so there are a couple of exceptions here. There's one in particular that there is a little bit of scripting magic on the back end and a little bit of Terraform magic that will dynamically pull the IPv4 address of the student so that it is set into the security groups at instance provisioning time. And so that's pretty cool, right? Because when your lab spins up and your Guacamole instance spins up, well, guess what? You're now, from your own IP address, you're the only one that can access that, right? So that's fantastic. That is a fantastic implementation of layering security to make sure that only you have access to that. Now, is their home IP authoritative? Does it absolutely 100% make sure that it's them? Not necessarily. If you're in a big organization and your big organization only has maybe one public-facing IP address, perhaps somebody else could sign in. There are other ways to provision this as well. You could do a VPN. You can switch it up for whatever works for you. And so this is also critically here to satisfy another one of those requirements. This is provisioned without internet access. The internal malware analysis network does not have internet access in its default configuration. It can be outfitted to do that. So the idea would be, if you want to pull samples from a big database of malware, maybe you can set your instances to have a security group that will allow them to connect out to the real internet. But as soon as you're ready to actually start analysis, you shut that thing down, and only the instances that have been provisioned can no longer route to the open, wide out internet. And so this is another example. So this is the code on the back end for doing something like, hey, let Flare VM talk to everything inside of the VPC, but don't let anything outside of the VPC. And so these are hard-coded in the Terraform files. That's just a really nice way to kind of get this to be repeatable and to be secure. Now let's take a look over here. And we're still creating our Terraform infrastructure over here, so it will run for another maybe 3 to 4 minutes here. We can also look over in our instances. So I've pulled up my AWS dashboard here, And so if I refresh on my AWS dashboard, I should now have a couple of running instances. So these are now provisioned from Terraform, and this is going to take a little while to actually see they're still in initializing status right there. So while that goes, and we're at 2 minutes, we're going to run for about 5. I wanted to open the floor to questions at this point because we have a little bit of time here, and I want to make sure that I answer everybody's questions.
I think one of the questions that that's been asked, that can this be modified to some sort of adversary emulation script as well? So the VMs that you're using for analysis, can this be more for testing as an adversary as well?
Yes, absolutely. So I in my previous life and really a little bit in my current professional life, I've used things like let me go find it for you, Commando VM. So you can provision things like Kali Linux. There's also this right here, which is Commando VM. Commando VM is like, Kali Linux is the kind of Linux pen testing distribution, and Commando VM is the Windows pen testing distribution. So I have provisioned things like Commando VM, all from Terraform. There's another discussion to be had about how responsible it is to run offensive security operations from AWS. So there are a lot of like little nuances about like, where does your traffic go? Should your client's data, if you're emulating an adversary, should your client's data live on the endpoint? But that's kind of a more in-depth discussion. But to answer your question, absolutely. Terraform is fantastic to stand up redirectors, stand up C2 infrastructure, that kind of thing. I've used Terraform to do that with DigitalOcean, with AWS. Have never done that with GCP, but maybe someday.
Excellent. Thank you.
Of course. Yes. What encryption does it use? Yes. So this is the Guacamole instance will provision with a self-signed certificate. And of course, you can modify that as you see fit. If you have a legitimate certificate that you want to install with that, you can script that up as well. And so this will be connected over TLS. However, it will have a self-signed certificate. You're actually going to see that here in a moment. It can be a little alarming when you see that warning, but don't worry, it's fine. To what level can we isolate our sandbox environment in the cloud? Will there be any chances of misconfigurations? It's an interesting question. Isolation happens at the network level in this case. So the VPC will put basically a fence around the network, and it will isolate any traffic that's leaving out of that. As for misconfigurations, there are probably edge cases. I haven't accounted for anything, and that's maybe part of my call out to the community is if you as a an architect, a security practitioner, or anybody, if you see a glaring issue with this setup, I mean, please let me know. That we can always probably make this better. But I think the possibility for misconfigurations is mitigated by Terraform, right? So Terraform helps out with configuration management in the sense that the Terraform instances are always relatively the same, unless you script it to be otherwise. All right, so looks like we've got our environment provisioned here. Now, does anybody see anything alarming in this output specifically right here that I'm highlighting? I will call your attention to this Guacamole public IP. If you're about to say, "Oh no, you've just exposed not only," I'll bring that back up. Matt, you've not only exposed your IP to the public here, but you've also exposed the Guacamole username and password to the general public. Well, I would say good eye. However, if you remember that my Terraform security groups provision to only allow myself to get into my own infrastructure, well, then you can see that if I go to 34.230.2.42, and I'll do this over here so everybody can see. I got an extra colon in there. There we go. So we do, in fact, have the self-signed certificate warning here, but if I go to advanced and I proceed here, again, if you configure this with a signed certificate, this should be fine. Looks like I am at my Apache Guacamole instance. Now, as a little test, I'm going to open up Tor. All right. Now, Tor, of course, fantastic for routing your traffic through various levels of encryption and making sure that nobody can see your traffic unless it's your destined location. And so let me go ahead, and sometimes Tor is a little weird like that, so let's get a new circuit for this one. Looks like we're coming out of the Netherlands in that one. So let's go ahead and See if we can get a good circuit here. If not, I'll just have to close and reopen Tor probably. There we go. Okay, fantastic. So it looks like I might be coming out of maybe Russia or somewhere in... Oh, it looks like Germany. Interesting. Okay. The point is that if I were to have any other IP address other than my own, and I also try to go to my Apache Guacamole instance, what do you think is going to happen? Absolutely nothing. This is going to try, and because it's Tor, it's very slow, but eventually it will error out because it's going to say, hey, I can't actually access the resource that's at this location. And that is because the Terraform security group rules will prevent that from happening. And so over here from my own IP address in my, my home network, my apartment router, basically, I can access Apache Guacamole, but over here I cannot because I am routing from here to France to the United States. And finally, my guard router, or not guard router, but my final router in Tor is coming out of Germany. That's just a little demonstration for only you really should have access to this. Should's kind of a nebulous term, but yes, your IP, your home IP in this case, is the one that has access to your lab. So I don't really mind showing you the credentials here because you can't access this anyway. If anybody can access this, please let me know. That would be a little concerning. But I'm gonna put a good bet that no one is able to access this. So we'll log into Guac admin. And there's a little bit of assembly required here. And so what you have to end up doing is go over to settings, and you will go to your connections. And let's make our connections to go into the lab. We'll call this one Flare VM. This is going to be an RDP connection. We're remoting into the Windows machine that's over in the lab. So our host name, this provisions with the same internal IP addresses every single time. That is 10.0.0.4. So we'll go ahead and do that. 10.0.0.4. The standard port for RDP on the Windows side is 3389. And let's go ahead and do our authentication information here. So we've got administrator. We have a password, a preset password of please change this password 123. Again, if you make your own AMIs, you're free to go ahead and change that to whatever you see fit. Wrong window. There we go. There's not really any domain here, but we're going to ignore the server certificate here, and that should be good. So let's go ahead and save that. Now, if we go back to our home, we'll go ahead and open up our Flare VM RDP session. And if I have done everything correctly, we should have desktop GUI access to Flare VM here in a moment. And look at that. It's beautiful. All right, so we are in our lab here. So as always, you never want to, just blindly trust your infrastructure. You do, in fact, want to test it to make sure that you're as isolated as you think. And we'll do that here in a moment once the Explorer.exe boots up. This is the stock Flare VM installation from, I want to say, a few months ago. So, eventually I can update this to I'll update the AMI eventually. But if we open up, actually we have Windows Terminal here. That's even better. We'll open up Windows Terminal, and it might take a second because it's still kind of waking up here. And we already get a clue here. It looks like we have no internet access down here in the bottom right corner, but we want to make absolutely sure of that. And this is something I teach in the course as well. So if we want to see if we can route to the open internet, a couple things that I like to do. The first one I like to do is just ping Google's DNS server. I would imagine if Google's DNS server is down, something crazy has happened. So that's almost like a pretty reliable test that you're either connected to the internet or not connected to the internet. Same things here, ping google.com. That might fail as well, but that might just be a DNS error as well. But we see that this request is timing out. So it even knows that Google is at this particular IP address, but it is timing out in that case. And that might be a DNS caching issue. I should probably look into that. But in any case, we can reasonably assume that we have no connection to the outside world at this point. And so another thing that I like to test is, ping from the local lab perspective, ping your own host at the local perspective, but we don't really have that right now. I guess you could ping your own public IP address, but that I think is kind of overkill in this case. So once we have confirmed that we have our network set up correctly, I mean, now all we really need to do is start to perform our malware analysis, and we'll open up things like Cutter, we'll open up things like x64 debug, we'll open up things like strings and floss and Kapa, and we'll perform our malware analysis skills and capabilities. And that is a little bit about how to set up the infrastructure. Let's see, just an idea. Are there other security levels in case I can duplicate your IP, like location or MAC? No, and that's a very good point, and that's something I brought up earlier. Is a MAC address, is the public IP address of a student truly authoritative? I would say in like 95% of cases, yes, maybe not. There might be a couple edge cases there where it may not be. So that's a good thing to continually discuss. So yeah, and then now we can, switch to dark theme and Cutter, of course, and then we can open up our malware binaries in here. I will not perform any actual malware analysis here, but you can you get the idea that this is, you'll get your malware samples onto this cloud infrastructure, and then you will perform your analysis over here. Now, let's say that we have run our malware and we have changed our Flare VM instance in some way, and we need to revert it back to the previous state. And so that is an important part of malware analysis because you want to revert back to a known good state before you continue on with your analysis. If you run malware, maybe it changed something in the registry, maybe it added a user, maybe it deleted a user. If you keep performing malware analysis in the known changed state, then you might get false information about that sample. And so from Terraform, we could do something like the following. And so we can do something like Terraform apply. In this case, we will do a replace equals AWS _ instance dot flare VM. And so if we wanted to at one point swap out our instance for a fresh one that we know is known good, we can simply re-provision it right from Terraform. And so when I do this, it's going to tear down just the instance of Flare VM and then stand one back up. And so it's thinking, and then if I just do a yes here, and notice that this is going to go from 10.0.0.4 from the old Flare VM IP and provision the new one exactly with the same IP. And what does that mean? If we don't tear down our Guacamole instance, our Guacamole server is actually still up and running, but Flare VM itself is going to error out while the provisioning is still in progress, right? And so that's pretty cool because that means that I can go back and do other work here. Let's say I want to set up my SSH into Remnux, right? Go over here. We'll call this SSH. Our protocol is SSH. And down here in our authentication information, our host name from my documents here is, let's see where Remnux ended up, is at 10.0.0.6. 10.0.0.6 on port 22, of course. And the username is Remnux, and the password is malware. And we can save that one. And then we go back over to our active connections, and we can SSH right into our Remnux host. Who am I? We are Remnux ls. We're in the home directory. We can even do VNC. There's a VNC run.sh script over here. So you can run VNC as well. And while our Flare VM machine is still provisioning, that's going to take another maybe 5 minutes or so. We can perform any other analysis on Remnux that we want. And then all we have to do is from time to time check back in on Flare VM, and it will continually try to get that remote desktop instance back up until the RDP service is running again. Also, I would like to take this time to mention, please destroy your instances after you're done using them, because they can be very expensive if you leave them on. And I like to make sure my students understand that as well. That is essentially all of the demonstration that I have. We're going to, leave the actual technical discussion of malware analysis for another day. It's very in depth, and I think it warrants its own discussion as well. But this talk is really about provisioning infrastructure in a secure and repeatable fashion. Whatever that infrastructure is really left up to you. But in this case, what we're doing with it is malware analysis. And so that is my talk on cloudy with a chance of malware. I will now happily open up the floor as I swap my presentation over again. I will happily open up the floor to questions and comments. If you'd like to email me, my email is right there. Again, the code, the Terraform code for this is available on my GitHub page as well. And yeah, thank you so much for having me. And I'd like to open up the floor for questions at this time.